Good morning, good evening, good afternoon, and welcome to a very special KubeCon office hours, the Cloud Native Storage with Rook edition, run by the wonderful Josh Burkus from Red Hat. Josh, please take it away.
Hey there, thank you, Chris. Welcome everybody. And this is our second office hours concurrent with KubeCon in order to give you more time to actually ask your questions from the many maintainers who are here at KubeCon so that you can find out what you need to know about using various cloud native projects. This office hours is going to be about Rook and also Ceph, so cloud native storage. And we have Blaine and Travis with you. So guys, do you want to introduce yourselves? Blaine?
Sorry, I lost the mute button for a minute.
Okay.
Yeah, I am one of the maintainers of Rook upstream. I also work for Red Hat as a storage engineer, which I think that's a pretty good intro.
Okay.
Yep.
Travis?
I'm Travis. So I'm one of the original Rook maintainers. Started on the project over 4 years ago now. Actually, just had our 4-year anniversary. It's been a great ride. I've been with Red Hat for the last couple of years, and yep, happy to be here with Rook.
Awesome. As we get started, y'all are going to have a short presentation to kick things off.
Mm-hmm. Yep, we'll do. I'll share my screen, and we have a few slides just to give an intro, and see if I can get that. Yep, and I'll turn it over to Blaine.
Yeah, Travis and I are going to talk a little bit about Rook and Ceph. Ceph is Rook's oldest and original backend. It's the most mature and the one that gets the most attention. I think the next slide jumps into what Ceph is, which is an open source distributed object storage solution, and then that can, with Rook, be used to give your Kubernetes cluster access to block, file, and object access to your data. So if you want block storage, Ceph can give you that. If you need file system storage, Ceph can give you that. S3 access also. There are 3 sort of core architectural layers that we kind of break things up into, being Rook, Ceph CSI, and Ceph itself. Ceph itself is just the data layer. I tend to kind of think of these in a bottom-up level. The CSI driver will provision and mount Ceph storage into pods for your applications. And then Rook is in charge of administrating and managing Ceph, and also can set up the Ceph CSI components for you. And so there's a deeper architectural look that Travis is going to go into.
Yep, thanks, Blaine. Yeah, so we have a few different views of what these layers look like, and ultimately Rook is the it's the management layer for bringing your storage to Kubernetes. So Rook being the management layer, what does that mean? So that means that Rook will communicate with Kubernetes and tell how to deploy all the various pods and services and different resources that need to be created so that you can have storage in your local Kubernetes cluster. At a higher level, we typically think of storage, or it's been typically treated this way, where it's an external entity to Kubernetes. But now Rook really brings storage inside your Kubernetes cluster, makes it just like another application that you're managing, except of course it's stateful. It's going to take care of your data, keep it safe. So how does Rook do this? So this diagram is kind of showing a conceptual cluster of 3 nodes, where each of those black boxes is a node with various pods running on it. So on this center node right here, we see the Rook operator pod is running, and this is in a fully configured cluster that Rook has created. And it's done that by creating all the different pods that are needed for Ceph and the CSI driver. So it's kind of color coded here. You see the blue pods, like the discovery pod. It's kind of related to the Rook operator. It helps discover devices on the nodes. The green pods are for the CSI driver. That's what helps attach your volumes to your application pods. And then the red pods are the ones that are actually the Ceph daemons that are managing the local storage on your cluster. So kind of you see this, there's a Ceph monitor, which the monitors are kind of the brains of the Ceph cluster. They have some persistent storage to keep some metadata. And then the other critical stateful daemon is the Ceph OSD, stands for Object Storage Daemon. And that's what holds the core data in the system. So you see this disk backing this OSD, where this disk can be a local disk. It can be a PVC itself that comes from a cloud provider if you're running in the cloud. But yeah, so those are the pods that are basically running to get your Ceph cluster running. So Rook deploys all the Ceph daemons, all the Ceph configuration that you need to hide all the complexities of Ceph in your cluster and give you storage in Kubernetes. All right, so that's kind of layer one management that we're talking about. Now, layer two says, okay, let's say we've set up Rook, you've got the storage available in the system. Now, how do you provision it? How do you connect your application to it? Right, so kind of in the spirit of application pods. So you've got an application pod that needs block storage. We'll start with block storage here on the left. What you'll do typically is, well, you'll create a volume claim or a PVC with read write once access. That claim will request the storage from a storage class, and then that request goes to the Ceph CSI driver and says, hey, provision me this volume and attach it to my pod. So that's in a nutshell how you provision block storage. Similar thing if you need shared file storage. So if you have two applications that need to share the same storage. So each of them, well, you create a single PVC, actually not well represented by this picture, but you got a PVC that then goes to the storage class, which goes to the CSI driver. Again, so you get shared storage between two applications. And then finally, the third type of storage that needs to attach or connect to is object storage, which uses an S3 interface. And to mimic what we do with volume claims, we've created this concept called bucket claims, where you've got a special type of storage class for object storage that provisions a bucket for you, so you can have an S3 endpoint in your cluster to give you that object storage. All right, so that's how you would basically connect your storage to Ceph. So then layer three, now we get down to the data layer. Once Rook's been set up at layer one and the CSI driver has provisioned the storage, the volumes at layer two, now at the end of the day, your application just wants to write and read data, right? So this diagram tries to illustrate how your application now will connect to Ceph as the storage provider. And there is actually no management layer in this picture. So Rook is out of the, conceptually out of the picture at this point for writing and reading data, because it all goes through Ceph, which has been a stable data platform for many years, longer than Ceph, or longer than Kubernetes has existed. All right, so your block storage will be mounted with the it's already been mounted with the CSI driver, but now it connects through the Ceph RBD kernel driver, which knows how to take care of the complexities of connecting to all the different Ceph daemons, the mons and OSDs in the cluster for those writes. And without going into all the details, basically the shared file system does the same, where it connects to a Ceph daemon to manage that shared file system. Or the S3 client then just talks to the RGW endpoint, which is the Ceph service for object storage. I know that's really quick overview, but that's basically what we wanted to share to get this discussion going. So, yep, where should we go from here? Any questions?
Not seeing any questions in the chat yet. Usually takes a little while to get started. So did you want to do the getting started, or do you want to go straight into talking about 1.5?
Why don't I, maybe I'll talk about this couple more slides here, just to give a little more idea. Well, how would you get started with Rook? Say you need storage in your cluster, what does it take? Ultimately, we've tried to make Rook as simple as possible so you can deploy Ceph. And there's basically just a few manifest files that you need to get up and running. And I just realized I need to update this slide because there's one more. But we have some resources which gives us the RBAC or privileges in common.yaml. We have a new one that creates CRDs, so it's crds.yaml, which is not shown here. And then you create your operator, and then you create a cluster manifest. So the cluster manifest tells Rook basically how or what settings, how do you want to deploy your cluster. On the right here, you can just see a couple of those settings where basically we say, well, how many mons do you want? Oh, give me 3 mons. That's kind of the typical deployment. How do you want to consume storage on all the nodes? Do you want to consume it from PVCs? Do you want to consume it, just let Rook look for all of the local devices on the nodes? And so this shows the simplest way, which is just lets Rook go for it and create storage on all of the nodes, whatever free device it finds. And that's basically, well, a little simplified, of course, for this discussion, but that's pretty much it. It gives you a Rook cluster with just a few simple manifests to create. And also, again, so that was kind of layer one, back to the layering thing. Now, to request storage from your application, just a simple example, the admin is going to create a storage class. He's going to, or they're going to create a persistent volume claim, and then the application pod. So on the right here, we've got what the application pod might look like. In this case, the simple Nginx image, which is requesting storage with this persistent volume claim for the RBD PVC, which again points us back to the storage class that the admin would have created. So is that it? Yeah, I think that's about it. So 1.5 features, you say?
Oh, you want to stop sharing and we'll.
Yeah. Okay. There we go.
Okay. Pardon me for a moment. I seem to have gotten a cat here. You can just see the tail. It's
like your microphone.
Yep. Yeah. If only that worked that way. My first question here is 1.5 came out on Friday, I think.
That's right. Mm-hmm.
So what are the big things in 1.5?
Yep. So 1.5, it adds a number of new features. I guess just to go through them. I'd invite anyone to look at our blog to read through it in more detail. I'm glancing through that right now, honestly, just to remind myself of all the features. The first one we've got, so with the storage configuration, we want to encrypt the data that's at rest, and we want to do it in a way that's as secure as possible. So we'll use a key management system like Vault. So in 1.5 now, we support Vault as a KMS that lets you store your keys in a secure way. Rook will request the keys from Vault, and then encrypt the data that at rest with those keys. That's one feature. Next one.
Do you support keycloak as well?
Not yet. No,
Okay.
Yeah, with the Vault support, we kind of put some framework in place so we could more easily add others in the future. But yeah, Vault is just the one right now. Another one is what we call mirroring or RBD mirroring, where so you've got two clusters and you want to replicate the data across Kubernetes clusters. They might be in different geographical areas, or they might just be just independent clusters where you want the data replicated across for failover or DR scenarios. So we made it more configurable through CRDs now to set up that replication across clusters.
So
there's kind of some manual setup across clusters, but go ahead.
Hey, so is the mirroring is being carried out by Ceph though, yeah?
That's right. So Rook just helps set it up to get it configured.
Okay. So how does that work across clusters? Don't you have to have like 3 clusters for like a tiebreaker or something?
That's a little different. I'll get into that. That's actually a new feature now too. But this one says, you want 2 clusters running where you've got your application running in 2 different places. For if one data center goes down, you can run your application in the other data center. But totally independent Kubernetes clusters as far as Rook is concerned, and Ceph. So they need to be connected. If you're within a Kubernetes cluster, you don't need this level of replication because Ceph is already replicating it within a single Kubernetes cluster. This is really cross-cluster replication. Yeah. And yeah, well, I guess while we're on that related topic then, so you mentioned the stretching a cluster or having an arbiter. So Ceph just added support for this, and well, actually, it's still in experimental mode because the Ceph release that includes it won't be for a few more months in the Ceph Pacific release. So with stretch cluster, you have 2 data centers that participate in the same Kubernetes cluster. So you've got some form of failure domain within there where, but they're all in the same Kubernetes cluster. And only 2 of the data centers can store data, but you need a third or tiebreaker zone so that the Ceph monitors can have that third one to break the tie. If one data center goes down, you always need 2 Ceph monitors up so that this, the core of the Ceph can keep running. Kind of, yeah, does that make sense? Hard to describe in a nutshell.
Yeah. So wait, so we've got mirroring, which can mirror between clusters. And then we have stretch, which actually spreads your clustered storage across 3 or more clusters.
Well, stretch clusters, it's really one Kubernetes cluster with 2 data centers or 2 failure domains managed in a special way so that if one data center goes down, the other one is fully functional and still has like 2 replicas of 2 copies of the data. So with stretch clusters, you actually have 4 copies of the data, 2 in each data center. And the tiebreaker is just helping manage if one of those data centers goes down.
Okay, so at this time, the stretch cluster does not integrate with any of the sort of incarnations of Kubernetes multi-cluster.
That's right. Yeah, it's just a purely Rook and Ceph feature.
Okay. But I can do mirroring between different clusters, and that's kind of the difference between the 2 features.
That's right.
Okay.
Yeah, with stretch cluster, you have to be within the same Kubernetes cluster. Mirroring is across completely separate Kubernetes clusters, with their only relationship being that networking is allowed between them.
Looks like you also got Multis support.
That's right. So in, let's see, 1.3 last spring, we initially had experimental support for Multis. We've been working through a few details and fixes, and we just got the last fix merged yesterday, where it's looking like we really feel good about Multis being able to be used as that network provider. And also that also helps with communication across clusters too, if you've set it up. It can help with the way Ceph works internally too, so you can tell Rook or tell Ceph which cluster to use for the backend network. Yeah, so it's just all around good for networking and communication across clusters.
Okay,
Let's see. Yep.
is Rook Ceph already working with dual stack support? That's kind of in beta in Kubernetes. So
no, we've got single stack support for IPv6, but right now we just assume we're in single stack mode, and we've been kind of waiting for Kubernetes to settle on the dual stack approach. Well, last I checked, had been still changing a bit.
okay.
Blaine, any 1.5 features that I missed that you'd like to bring up?
I don't think so. I think that was all the really big ones.
Yeah, lots of other internal improvements. There's one like API extensions moved. We finally moved that to V1 from the V1 beta one.
So
that's going to be gone soon.
But that does mean that users may have to update their deployment files?
That's right. And with our each upgrade, with each release that we have an upgrade guide that says here's how you deal with whatever might have changed. And the API extensions change was a fairly big internal change, but our upgrade guide basically says here, just go apply these new CRDs and you'll be good.
Okay. Do I need to apply those for an already running Rook cluster, Rook Ceph cluster, or do I only need to apply those when I'm going to deploy a new one?
Well, so you have to create those CRDs anyway for new clusters, but upgraded clusters with every release, really, whatever changed in the release, we have to update them. And in this case, the CRDs all changed, and so we say, hey, in the upgrade, go apply these new CRDs. Which, I mean, internally, Kubernetes was already converting them to V1. And so we don't expect existing CRDs during the upgrade to be impacted. So it's more of a, I don't know, almost a detail that you have to go upgrade them. It gives better schema validation and things. And also, if for the users who are using our Helm charts to deploy, the Helm chart just takes care of all of that in the upgrade.
Okay. The it's everything in 1.5. So what's next? What are y'all working on for Rook 1.6?
1.6. That's a great question. You know, with each major release, I feel like, okay, we got out the door, and there's always more features from Ceph coming in. I'd say the first thing on my mind next is that Ceph Pacific will be out in the springtime, about the time we release 1.6. So Ceph Pacific will become fully supported, where the Ceph releases, of course, aren't supported until they're out. There will be new features. I'm going to forget about them on the spot, but yeah, Blaine, what are your thoughts on other things coming?
I mean, this is something we don't usually talk about a whole lot since it's kind of a boring non-feature detail, but I'm excited about some of the CI changes that we, have had in 1.5 and also are continuing to continue forward with in 1.6. We're hoping to be able to iterate more quickly and just be able to write like more and better tests that way when we don't have to wait like an hour between CI runs, but can instead wait like 20 minutes instead. And
Wait, so what changes are you making?
the CI has moved to like most of it runs using like GitHub Actions to run individual tests, sort of one at a time, but in parallel, which has sped up our CI quite a lot. And we're also looking to start doing CI for like nightly builds of both Rook and Ceph, either on like a daily or weekly basis, just to get like good integration validation like between those two pieces, make sure things are just like very like tightly integrated and that there aren't accidental gotchas that we end up figuring out like a week or two down the road.
Yeah, I often wonder in Kubernetes if GitHub Actions had existed 3 years ago, whether we would have built all of the things that we built.
Yeah, we're finding they make the developer life much better in Rook at least. Yeah, a couple other feature areas that come to mind as well going forward is the DR disaster recovery scenarios are, they're complex scenarios. How do you get your application to fail over in a reliable way or testable way? So a lot on improving the DR automation around that. And so, Rook likewise is, that's one of our big areas of focus. How can we make the mirroring across clusters better? How can we improve stretch clusters to make them even simpler or even more reliable? So anything across clusters, there's RGW multi-site, which means you've got your object storage that you want to replicate across clusters, not just the the block with RBD mirroring. The CephFS with the shared file system also will have a mirroring technology coming soon. I don't recall honestly if that's specific or beyond. Yep, and then continuing features also around just working well with Kubernetes. One that we're almost done with is working with pod disruption budgets in a better way, where you need to upgrade Kubernetes, but you don't want to disrupt storage while you're doing your Kubernetes upgrade. So the pod disruption budgets will allow Rook to control how those upgrades work. So you upgrade Kubernetes and the storage just working because it'll work well with the failure domains that you set up with Rook.
Okay, I have more questions about future work, but before we get to that, Barnes, who's just getting started with Rook and Ceph, wants to know if after deployment, only a single monitor pod starts, and then the cluster stops there. What's the next step for troubleshooting?
Okay, if one mon pod starts, so yeah, because you need 3 to get going. Usually what happens is either there's a networking challenge that, well, let me back up. So what the operator is trying to do is it starts one mon, and then it tries to connect to it and validate if it's healthy, and then it adds the second and the third one at each one healthy. So the operator apparently isn't able to connect to that first one, and so it just keeps retrying. So I'd say check for networking. If you're in a bare metal cluster, there could be some firewall in the way. That are commonly asked questions in our documentation that I'd suggest to look there, or ask us in Slack. That's definitely a common challenge to get past.
Yeah, on the networking, there's a Kubernetes app just to kind of smoke test your networking in your cluster called KubeRang, which is also noted in the Ceph channel of our Slack, of the Rook Slack. and I've found that useful for spinning up just to sanity check whether the Kubernetes cluster is actually behaving as it's intended to do.
Cool. Okay. Thank you for that. We'll see if he has follow-up questions or if they have follow-up questions. One question for me is going to be volume topology and a Rook Ceph stack. That is, if I'm asking stuff of storage, ideally, I would want the application pod and the storage pod to be running as close together as possible in a network sense, you know, in the best of all possible worlds, you know, particularly for applications that make a lot of storage calls like databases, to actually have them on the same physical machine or the same VM. Is there any planned work with volume topology manager, et cetera, to make that a potential reality?
There's not, I'd say. So Ceph is fundamentally based on distributing the storage across your cluster. It breaks it up and, you know, basically shards it in a lot of ways. Ceph doesn't call it sharding, but it breaks up the data and puts it everywhere. And so if applications need the local data and they're doing their own level of replication, like many databases like Cassandra, then we'd recommend they use a local PV. It's just a local volume, and they manage it there. You wouldn't want Ceph in that case to manage it because it just fundamentally architecturally does not give you data affinity.
I was actually thinking at a higher level, because the thing is, okay, I don't necessarily have mon pods running on all my machines. Mm-hmm. If you follow me. And so if I deploy a high storage requirement app, I kind of want that to land on a machine that does have a mon pod on it. Now I can do that right now using affinity, but it feels like there should be something involving volume topology. Like this feels like a case that volume topology ought to address in some way, but I don't have any way now to do that.
I guess I tend to think of that a little bit more with like networking, because Ceph is so distributed. It's my understanding it's really about access to the OSDs, especially for like block and file access. That while I think you could, you know, currently we might use labels and use like pod affinities to be like, put this application on the same node or with affinity for a Ceph like metadata server for the file system. Or you know, if I'm doing block, there is no real metadata server for it. So as long as I have a big networking pipe to get to the OSDs, I don't know if that's very different from just putting an application on a node with an OSD on it anyway.
And a couple more thoughts about Ceph performance in general. So Ceph was really designed to work best when you have lots of requests in a distributed nature. So if you have lots of clients accessing the storage, that's when you're going to maximize the throughput, really, because there's no central point of failure. Everything's distributed, even the clients. But also, even for high performance workloads like databases, Ceph performs really well when you just need to back Ceph by high performance devices like NVMe or at least SSD, so that whenever the request comes in, it's really quick to respond with the data from disk. So that's why I'd say if you need high performance, you back Ceph by those high performance devices.
Yeah. Okay, I have more thoughts, questions on that, but we have questions from the audience, which I want to take first. So Easy Steezy wants to know, what are some catalysts that you've seen for people migrating to a Rook Ceph Kubernetes storage solution from using regular storage classes and PVs in Kubernetes? Is this primarily for high scale, or are there benefits in smaller environments?
Yeah, there's some thoughts there. So if the primary use case where we created Rook originally was really for bare metal, because when you're not in a cloud provider, there was no option for block object or file storage. And so this Rook gives you that storage when you're in your own data center. So that's the first and primary use case. But we're also finding a lot of people moving to Rook storage in cloud providers because of some benefits like, oh, we can put large volumes behind Rook and Ceph, so you get the performance characteristics of large volumes in the cloud provider. But then you can create hundreds or thousands of small PVs for your applications. So you get good performance by basing on top of Rook in that sense. And there's some other things for different failover characteristics. Like some cloud providers don't always have fast failover times, where Ceph really and Rook have fast failover times to reattach your volume somewhere else if your pod fails. So that's what comes to mind.
One of the things that I think about a lot there also is like, just from people that I have asked, when I've met them at KubeCon, and some of the responses are seem to kind of be around more of a multi-cloud sentiment, where they might be using a cloud provider or multiple cloud providers, but they want to still like write their applications to like access the storage the same way for simplicity. Or some even the same cloud provider might not actually provide all types of storage in all regions. So if you actually want to have block storage or object storage in all regions, their solution has been to use Rook for that for some users.
Right. Yeah. That reminds me, we even had some users come to us and say, hey, this cloud provider told us to come use Rook because they don't provide that functionality. Like, oh, cool, yeah, use Rook. It's consistent, it works everywhere. Everywhere Kubernetes runs, Rook runs with storage.
Well, as the databases on Kubernetes Geek, I'll also mention one other benefit for small clusters, which is if you're going to do storage-based failover rather than database-based failover for your database redundancy, failover between Ceph nodes for storage is way faster than failover for EBS.
Yeah, exactly. That's one I was trying to mention before as well. Yep.
Okay, so we have another question from Claudio, which is a similar comparison question. In this case, he wants to look at the comparison between running your storage inside the Kubernetes cluster via Rook and Ceph versus having dedicated storage appliances. Like if you're buying a brand new cluster and you're kitting it out right now, when would you decide to choose one of those paths versus the other path?
So dedicated hardware versus use the same hardware for Kubernetes and storage, right?
Yeah.
Right. That's a good question. Blaine, do you have any thoughts to start off?
I mean, I guess my starting thought is that there are so many little and big things that go into answering that. I don't know if I have any real rules of thumb, but I definitely think that like Ceph and Ceph shines in like really having really large amounts of storage and in being able to scale out whenever you need it to. And so I think those are the cases when I would be thinking about Rook versus if I'm like, well, I'm probably not going to need more than a few terabytes, which I could just have in like a NAS somewhere and have a like RAID array on. but there are also a lot of other considerations where maybe you want to use Rook for the kind of flexibility that it allows, or just the ease of deployment and installation.
Mode we have also called external mode, where if you have multiple Kubernetes clusters, you can manage the storage all in one of those clusters and then use our Rook's external mode for all the clusters to connect to that one storage cluster. Meaning you only have to manage storage in one place and everybody else consumes it. Yeah, the way that works is basically with the CSI driver, and each of the clusters connects to that one cluster. So that could be an important consideration to centralize storage management.
So basically, take Kubernetes, Rook, and Ceph and make your own dedicated storage appliance using those.
Right, that's one thing that you could do. If honestly, if you just had two clusters where you want to dedicate one to Rook and the other one to the rest of Kubernetes, I'd say I wouldn't make them separate Kubernetes clusters. I might create one Kubernetes cluster, and then you can use node selectors and other things in Rook so that you say, oh, only run on these nodes if you really want on certain nodes for high performance or other reasons. So I'd say keep it with one cluster unless you really need multiple.
Okay. I've kind of seen arguments the other way, just because I'll say once again, coming from the database realm, you sometimes do wonky things with your Kubernetes configuration in order to support storage. And some of those wonky things will go away though, right? Because once you guys support pod disruption budgets, then I no longer have to have a workaround for saying, hey, don't evict my storage pods. So in some ways, the whole business of, hey, if you have a high storage cluster, it needs to be configured differently. That's going to go away in the future through improvements in Kubernetes and improvements in Rook and the operator stuff. Hasn't gone away quite yet. So I could almost see having your high storage applications and, sort of a dedicated cluster of high storage applications and storage cluster, and then another cluster that's running, say, your ephemeral applications. There could be real benefits to that. From an administrative point of view rather than a performance necessarily point of view.
Yeah, and that's very fair. People do have multiple Rook clusters for reasons like that. It really comes down to application architecture, or how do you want to administer your storage as well.
Yeah, so until we get another audience question, one of the things I want to follow up on. So as you know, I've been doing some work on testing performance of database applications on top of Ceph Rook. The performance has actually been excellent. Even despite the fact that we are not hitting what should be Ceph's sweet spot, right? We have a single application running in, say, 3 pods that are making all of the storage requests. But I'm still actually able to get somewhere around 50% of the throughput that I would get on a single local PV, which is, I'll tell you, having had work with various distributed storage systems for the past 20 years is excellent. But like I said, this is a question of, if my nodes are not homogeneous, that is, if some have storage and some don't, I kind of want to target those, which was my whole question about eventually looking at integrating with volume topology. Not so much for, where do we put Rook and Ceph, but more for where do we put the application that is heavily reliant on the storage, versus the other applications that maybe don't need any storage.
Yeah, and Rook does some things around topology already, for sure. Like we, if you tell us look for the local storage automatically, or whatever device they're available, we'll basically skip nodes where we don't see the storage, and we'll just create it on the other nodes. Or we'll look for topology labels and set up your failure domains based on the node topology labels.
Cool. So let's see, other future work questions. So there's various projects that are aiming to stretch your Kubernetes network across, like, say, multiple physical data centers. Submariner, for example, because I work with the Submariner folks some. If you had one of those up and running, would I actually use that as part of my stretch configuration, or would I be better off really focusing on stuff that's Ceph native?
That's a good question. So you're asking, should you create one Kubernetes cluster across the whole thing, or create separate clusters with?
Well, assume I've already done that, right? Assume I've
Mhm.
already used Submariner in order to stretch my Kubernetes cluster across multiple physical locations. So the question is, if I want to, we'll have an audience question just a minute after this, but let me finish this one up. If I want to also effectively stretch my storage there for redundancy reasons, for availability reasons, should I then just tell Rook to treat this as one big Kubernetes cluster, or should I do something else?
Yeah, if you've stretched Kubernetes across the different domains, I'd say just have Rook take advantage of those domains. You'd need to label your nodes for different zones or regions or other topologies. But as long as you have 3 data centers, it's simple. Rook already works in that mode, where you have 3 replicas, say 1 in each of your different zones. Our stretch mode now just assumes you have 2 different failure domains where you want to stretch across. So I guess it depends on how many data centers effectively you have. Do you stretch across 2 or 3? And yeah, Rook and Ceph will work with either of those configurations. It definitely keeps administration or configuration simpler if you can do that instead of trying to use mirroring across independent Kubernetes clusters. Yeah, so does that answer the question?
Sorry, hold on, let me unmute myself. Yes, it does. Okay. So I was trying to figure out this. We have an audience question from Det Conan, who is asking, is it possible to easily do a hyperconverged setup with Rook? I'm trying to find out what he means by, what they mean by hyperconverged. Because people use that in different contexts.
It's definitely overloaded. I would say hyperconverged just means, would you want to put storage inside your same Kubernetes cluster on the same nodes with your applications? And yeah, you absolutely can. And lots of people are doing that. And if you have specific performance requirements, that's when people tend to do something more custom, where you select certain nodes for Rook and keep your applications on different nodes. But overall, there's nothing that prevents it. There is actually, let's see, is it ext4, or I forget which file system? You just can't use certain file systems for your volumes, or else they don't work well with Ceph if they're on the same node. But our default examples make sure we avoid that.
Cool. Okay, yeah, that was their question. In fact, that's how I personally run Rook Ceph in production, is on the on the same application nodes, because, and this is one of your other sort of benefits for small clusters, is I have a bunch of blades. Each of those blades comes factory supplied with 0.5 terabyte of storage. If I don't store things on there, it's just wasted space.
Yeah, just as well use it.
Yeah, I think a benefit to a situation like that also is to some degree, like Ceph does work really well when it's a bigger cluster. Like it's, to my understanding, it's generally better to create a bigger cluster with smaller amounts of storage on each node than it is like to have a small number of nodes with a larger amount of storage, just because then like you know, when you're grabbing like the pieces of files from all over, like you can make use of like the larger amounts of network bandwidth on each node.
Yeah, I don't know. Have you seen the performance testing that Sergey and I have been doing? Even with just 5 or 6 nodes, for a large sequential read, there is notable benefit.
For the 6 nodes as opposed to 3 nodes, you're saying?
6 nodes as opposed to local storage.
Oh, right.
As in even with a cluster as small as 6 nodes and a single client doing a large sequential read, you still see benefit over having that read access distributed across multiple machines. It's not a huge benefit, but you know, it's like 25% faster, which, considering you're getting redundancy in the bargain, is pretty nice.
Absolutely. Yep.
Okay. Well, we give people a chance to think of any last questions. We're almost at the end of our time here, so any last thoughts? Any things coming up? Other things that are happening during KubeCon that you want to mention? Please share them now.
Yep. We have a couple of Rook talks in KubeCon. Let me just remind myself what the schedule looks like. But Friday afternoon, we have our deep dive talk for the Rook maintainer track. So it's at, let's see, where'd it go? Friday at 3:10 Eastern time is that Rook deep dive. And there's another one that involves Rook that's tomorrow at 4:50 Eastern time. It's called Whatever Can Go Wrong Will Go Wrong, related to storage and how Ceph handles that failure. And otherwise, yeah, for questions, feel free to join the Rook Slack. We try to answer questions and be active there. And we look forward to feedback, as always.
Okay. Well, I'm just putting something in chat there for our 4 question askers. I've just sent a link out over chat for you to request your complimentary Rook shirts. You know, for participating in our office hours today. Please go ahead and follow that link, and you can go ahead and request that. If you are watching this later because you cut out in the middle, you can ask for that link on KubeCon Slack. And thanks everybody for watching and participating. And thank you most of all to our 2 Rook maintainers, not only for answering questions and participating today, but for the awesome tool that is Rook.
Thanks for having us. I'm happy to talk about Rook anytime. All right.